There it goes. All right, so like I said, this is the last chapter of, well, it's the last section, I should say, of this chapter. All right, it's called coordinate geometry. Does anybody remember? Like if you heard that word coordinate geometry, what's the first thing that you think of? Coordinates? Come on, you can't just give me the word right there. Give me something beyond the word that's in front of you. What is it? Mario, what are you saying? I can't hear you. You're just writing in there. I don't know what that means. Graphs. Okay, good. That's a good one. Give me something else. Points. Okay, give me something else. Coordinate plane. Okay, but we still use the word coordinate in there. Origin. Okay, that's a good word. Give me something else you learned when we did coordinate. We learned like 3 things. We kind of learned them. It was in one section. We learned them one each day. Yeah, but it goes beyond that. A little bit more beyond that. I think it was last chapter. We did, okay, quadrant is good. S is one of them, but it doesn't start with an S. But I should say this. The word starts with an S, but the letter that we use to indicate it is not an S. Slope, right. What letter do we use to indicate slope? An M. Okay, so we got slope. What were some of the other things that we did when we did slope? We had the slope formula. Okay, that is something that we did learn, but that's not what we're going to do here. But you are right, though, so you are right. We did slope. We did 2 other things. Midpoint, good. And then one other thing. Distance, good, good, good. So we're going to do all 3 of those today, all right? We're going to do slope first. All right, everybody listening? We're going to do slope first, then we're going to do distance, and then we're going to talk about midpoint. And it's all going to come together. All right, it's all going to come together in one theorem at the very end. Everybody with me? All right, so bear with me because you probably don't know where it's going, but once we get there at the end, you're like, oh, okay, now I know why he talked about slope. Now I know why he talked about distance and midpoint. They're all going to come together with one big theorem at the end. It's really not that big, but there is 2 parts to it. Everybody with me? I bet you can't wait now, right? So let's get started. So what I'm going to do is I am, if I could talk, this stupid cold is still lingering. Well, the cough is anyway. The cold's gone, I think, but it's just the cough is lingering. Let's grab this. Somebody said it earlier when we were spouting off things about the word coordinate. What do we call this thing? Okay, it is a graph. Let's get a little bit more detailed. It's called, okay, there are quadrants in this, but what's this whole thing called, though? It's a coordinate plane. Good. It's a coordinate plane. Or there's another word for it. We haven't used it in a really long time. Named after a guy with kind of a girl's name. At least in America, it's a girl's name. In France, I guess it's not a girl's name. What is it? Ariel? Is that what you said? No? Anybody know? Rene was his first name. Nobody? Rene Descartes. You remember that name? Rene Descartes. Okay, and we call this thing the what? Not the Rene plane, but what do we call it? The Cartesian plane. I guess you didn't remember. All right, that's okay. You hurt my feelings, but that's okay. Is that what it is? Just out of the blue, you wake up and throw something out like that. All right, we're going to put 3 points on here. So if I plot 3 points, I can connect them and make a what out of it? A triangle. Good. So that's what I'm going to do. I'm going to give you point A, I'm going to give you point B, and I'm going to give you point C. We're going to plot it on this coordinate plane or this Cartesian coordinate system or on this graph. And then we're going to talk about the triangle a little bit. All right, so one of the points is negative 7, 1. Negative 7, 1. That's A. And then B is 1, negative 5. And then C is 7, 3. All right, so let's change colors and let's plot it on this graph. Negative 7, 1, where is that? Negative 7 goes to here, 1 goes to here, so that's point A. Everybody go to that? Yeah. Then B is 1, negative 5, so we go to the right 1, down 5. 1, 2, 3, 4, 5, right there. That's point B. And point C is 7, 3. This has 8 things to it, so if I go just 1 before it, that's 7, and then 3, 1, 2, 3 is right there, so that's point C. And I'm going to make a triangle out of it, right? All right, so let's connect the sides. Right there, there, and there. That's fairly accurate. All right, we're gonna learn something about some of the sides. Okay, we're gonna do 3 different things. What did I say the first thing we were gonna do with this? The slope. Good. So let's do that. Let's find the slope of all 3 sides. Okay. So M is what we use for slope. I'm gonna put an A underneath of that. What does that mean? MA. The slope of what? Well, I should have put another thing. Sorry, AB. All right. So it's the slope of what? AB. So I'm trying to find the slope of this little line segment, or this side of the triangle, okay? Everybody with me? You could rise over run. You could do it that way, but let's do it just mathematically. Do you remember how we find the slope? It's not y equals mx plus b. That's not slope. I mean, the m is the slope. Yeah, you got it. It's y2 minus y1, right? Remember that? Subtract the y's, put it on top. Subtract the x's, put it on the bottom. We're going to do that. We're going to do it 3 times. So I'm going to go a little bit fast, but I just want you to follow along, okay? So here's AB. Here's those 2 points. I want to find the slope. How steep that line is right there. That's what I'm trying to find when I find the slope of something. So we subtract the y's from each other. It doesn't matter what order you subtract the y's. Raheem said it was y2 minus y1. You could also say what? y1 minus y2. You just got to make sure you do the x's in the same order, okay? So let's go the first one minus the second one. You okay with that? So it's going to be what? 1 minus what? Negative 5. 1 minus negative 5. You guys are scaring me. All right. So that's the y's. What about the x's with the same 2 points? Go in the same order. If I went the top one minus the second one, or the first one minus the second one, I'm going to do the same thing here. The first one minus the second one. So it's going to be negative 7 minus 1. See if we can do this in our head. What's 1 minus a negative? Minus negative is plus, right? So 1 plus 5 is 6 over, what's that going to be? Negative what? 8. Reduce it. 2 goes into both of those. 3 over 4, right? So it's going to be negative 3 over 4. I could keep the negative at the bottom. I could put it at the top. I could put it right in the middle where I decided to, okay? Everybody with me on that? Yeah, piece of cake. Okay, you do a couple subtractions, do a little simplify the fractions, no biggie, right? Let's do the rest of them. AB, let's do BC. So the slope of BC. Let's do that one. So B and C. So the middle one and the third one. So let's subtract. Do the y's first. Negative 5 minus 3. And then do the x's. 1 minus 7. That's negative 8 over negative 6. So this is a positive, right? Because negative over negative. Reduce these. What do you get? 4 over 3. Now, just sit and look at your 2 answers and think about it. We talked about this in the last chapter. This is negative 3/4 slope. This is positive 4/3 slope. Does that tell you anything? I mean, by me asking the question, do you think it tells you anything? Yes, okay. If it didn't, I probably wouldn't ask the question. Okay, Justin, you see it. What do you see? Okay, they're negative reciprocals of each other. Exactly right. Remember that? Remember that phrase? Okay, one's negative, one's positive, and the fractions are flipped. Got it? So they're negative reciprocals. What do we learn about things that had negative reciprocals? The slopes. What if the slopes were negative reciprocals? What is equal? What? This is negative 3/4. This is positive 4/3. They're not equal to each other. They're negative reciprocals. We established that. So what's true about 2 lines that have slopes that are negative reciprocals of each other? They're not parallel, but they're more specifically what? It's not, this isn't really true, but what do you think of when you think of the opposite of being parallel? Come on. It's a word. It starts with a P as well. Parentheses. You guys are killing me. All right. Perpendicular. All right. Oh, yeah. Used every P word in geometry except for the one I was asking for, is perpendicular. So, what does that mean? Look, if AB has a slope of negative 3/4 and BC has a slope of positive 4/3, what's true about those two lines? They are what? Perpendicular, which means they form what kind of an angle?
Equilateral.
Have I even taught at all this year? Have I stood up here at all? Is this my first day? It seems like this is my first day teaching you this stuff. All right. It's a right angle, which makes a right triangle. Exactly. Okay. It is a right triangle. You're absolutely right, and I said that. Okay, so if it's a right angle, if they're perpendicular means they form a right angle, right? Look, see my arm right here? That is perpendicular to this arm right here. What kind of angle does that make? A right angle. That's perpendicular. Okay? We getting this? Sure we are. All right. I'm not even going to worry about the other one because those are the two that I'm concerned about, okay, for what I'm going to do a little bit later. Everybody watching? All right. If you wanted to find the slope of AC, it's fine. You could go 1 minus 3, which is what? Negative 2. And then negative 7 minus 7, which is negative 14. What's that? Positive 1 over 7. So the slope of that is 1 over 7. But does that have anything to do with 4/3 and negative 3/4? Not really. So I don't really care about that for this particular example, okay? Everybody with me so far now? Okay, so I found the slope of this. What was the slope of this one right here, AB? Actually, I'm not even going to write it in there. You got it in your notes. If you want to put it in there, you can put it in there. So the slope of AB is what? Negative 3 over 4, right? See how it from left to right it goes down. Do you see it? So that's a negative slope. This is a positive slope. And it's positive 4/3. So they're perpendicular, which means it's a right angle. All right. And we are going to go back to that in a minute. Okay. Well, in a few minutes anyway. All right. So keep that in mind. Got it? All right. So AB, what's the slope of AB? Negative 3/4. Keep that in mind. Circle it if you need to, because we're going to come back to it in a few minutes. Everybody got that? All right. Just to save some room here, just going to get rid of that. Now what we're going to do is this. Now what we're going to do is find the distance, the length of, okay, all three sides. Actually, I'm only going to do two of them. Okay, let's do AB and BC. All right, we could do AC. It's not really going to come into play, so I'm not going to do AC, just save some time. So let's do the length of. How long is it from A to B? All right, that's what I want to do. I guess I could put a ruler up to it, but that would be kind of silly. I should be able to find the length of AB by doing what? What formula? Distance formula. Very good. All right, so let's write what the distance formula is down so that we remember it. Does this bring anything back to you? Any memories? The shell. Very good. I like that. This is the shell of it. So what do we do inside of here for the distance formula? Take the x's and we do what to them? Do we? Actually, we do subtract. Okay? Good call. I almost did that in the last class. I actually did put a plus down. I looked at it. I'm like, wait a minute, that's not right. These are both being subtracted. Okay, both. You're going to subtract the y's. You're going to subtract the x's, then subtract the y's. But you do have addition in between, though. All right. So this is going to be y1 minus y2. All right, there it is. There's your distance formula. Without wasting any more time, let's find the distance of AB. So I'll put a D and I'll put a little AB underneath of it. What does that mean? The distance of line segment AB. So let's put some numbers in and see what we get. Here's AB. Here's our points. So let's put in the parentheses and the squared, all that good stuff. That's the shell. All right, and let's put the stuff in here now. So what do? I subtract the two x's. So good. Negative 7 minus 1. Those are the x's. Let's subtract the y's now. Yep, 1 minus negative 5. Good. All right, let's figure this out. Let's keep the square root. Don't forget it. All right, that's super important. Negative 7 minus 1. Let's do a little bit in our head so I don't write down every little step. What's negative 7 minus 1? How about negative 8? All right, and when you square negative 8, what do you get? Positive 64, good. So that's a 64. Plus, let's do this. What's 1 minus a negative? What's minus a negative? Plus, so 1 plus 5 is 6. 6 squared is 36. What's 64 plus 36? That would be 100. What is the square root of 100? What number multiplied by itself is 100? You guys aren't thinking. It's 10. What's the question? No, not by 2. You're asking yourself what number times itself, not times 2, times itself. Means what 2 of the same exact numbers. What 2 of the same numbers multiply to be 100? 10. 10 times 10. That's it, right? All right, so what's the square root of 100? It's 10. You're not dividing by 2. Got it? Okay, you're asking yourself what number times itself. The same 2 numbers multiplied together, all right, has to equal 100. What is it? It's 10. 10 times 10. You got it? It's not the square root of 10. Okay? It's not the square root of 10. It's just the number 10. So how long is that line right there from A to B? It's 10. You got it? Whatever it is. We don't know. We didn't measure it in inches or centimeters or anything, so we don't know. I'm gonna do one more, okay? You could do all 3 if you wanted to, but just for the sake of what we're trying to do today, let's just do BC. So let's do it again, except we're doing the distance of what? BC. So put a square root, put the parentheses, the squareds, the pluses, and all that good stuff, the shell, okay? And now let's do our math. Subtract the x's. We're doing BC this time, so these 2. So let's do the x's. What do we put? 1 what? Minus 7. And then for the y's, we do? You got it. Negative 5 minus 3. Let's do the math. Put the square root. 1 minus 7 is? Well, it's negative 6. But it really doesn't matter because negative 6 squared is what? 36. Okay? Plus, let's do this. Negative 5 minus 3. Negative 8. What if I square a negative 8? It's positive 64. Why is it positive? Because a negative times a negative, right? Okay, 2 negatives multiplied together is a positive. So negative 8 times negative 8 is positive 64. Check this out. Does that number look familiar? Yes. What's 36 and 64? 100. And what's the square root of 100? It's 10. So guess what? What's true about this AB and this BC? Well, we already mentioned that, but we just finished doing something. So what does that tell us about AB and BC? They are congruent. They're equal to each other. So AB equals BC. So I could say, here's this chapter, it's what kind of a triangle then? We know it's a right triangle, but it's also what? 2 sides are equal. Isosceles, that's right. So this is an isosceles right triangle. Would you agree? All right, that's just so we can keep thinking about what we've been doing this chapter. But what I'm concerned about is this, that this is 10 and that's 10 right there. We good? All right, so I got one more thing to do. So we did slope, we did distance. What's the third one we said we were going to do? Midpoint. So let's do midpoint. And I'm going to pick and choose what I'm going to find the midpoint of. Mario, question. You might. They might ask you only find a couple sides. They might ask you just find the length of one side. Okay? But you should be able to do both of those things. On the test, I can picture it in my head right now. I think it's like the last 4 problems on the test are going to be like this, what we're doing today. Okay? Where you're going to have to find the distance between one point and another point. Or you're going to have to find the slope between one point and another point. All right? You've already had that on another test, but you're going to have it again. All right? Because it's important. I mean, this is stuff that you see. I mean, I'm just thinking of all the math that I've had and how many times you have to do this kind of stuff. All right? It's super important. It's not just for geometry, then you forget about it. You did it in Algebra 1, right? You remember doing this in Algebra 1, don't you? At least the X and Y stuff, right? And then you're going to do it in Algebra 2. And if you keep on going in your math, you're going to have to do it there as well. All right? So, yeah, this is huge engineering stuff. I mean, super basic, really, really basic right now. But, it has to get harder and harder. We got to start somewhere, and that's where we are. We're just at the starting, okay? People concern themselves all the time. When am I ever going to use this, right? Yeah, you're not going to use just this stuff the rest of your life. It's such a simple little baby step, okay? But it lays the foundation for what you're going to do later on, okay? And if you do engineering, anybody taking the engineering class with Mr. Crowell? Okay, but you're not now? Anyway, I haven't even spoke with him about this. We've spoken, but not about engineering. But this is definitely something you would have to know to be able to do anything to do with engineering, all right? And it's a very practical math. It's very, very practical. And when you get into engineering is where you really see how it becomes practical. Okay, one more thing. When do we get out of here? Chapel 21. Ooh, okay, I better hustle. So, let's do this. Let's do midpoint, right? Midpoint. So what I'm going to do is I'm going to do midpoint of AC. You see this one right here? And I'm going to do the midpoint of BC. This one right here. So AC and BC. So do you remember how to do midpoint? It's a point, right? So it's not just a number. It's a point. It's an ordered pair. But it's mid, so we divide by 2. It's the middle, right? And what do we do to the x's? We add the x's together on this one. Okay, we subtracted them on the other ones. We add them on this one. And we add the y's together right there. So I'm going to find 2 midpoints. I'm going to show you something. Then we'll wrap it all up, and hopefully we'll be good. So let's find AC. The midpoint, I'll put MP, and then I'll put what? A little AC under it. Everybody understand what I'm doing there? I put MP for midpoint. The midpoint of what? Well, it's real little. It's AC, the midpoint of A and C. So let's do it. Put it over 2. Put it over 2. And now what do we do? Add the x's. So we're doing A and C, the top one and the bottom one. So let's add the x's together. -7 plus 7. -7 plus 7. And let's add the y's together. What do we get? 1 plus 3. Okay? And we can just do this in our head now, can't we? -7 plus 7 is 0. 0 divided by 2 is 0. 1 plus 3 is 4 divided by 2 is 2. So the midpoint of AC is where? It's at 0, 2. Let's put this in a different color. Where's 0, 2? There's 0, and then there's 2. Look at that. Does that look like it's the midpoint? Terrell, up here. Does that look like it's the midpoint? Yeah, it absolutely does, okay? So what else are we going to find the midpoint of? What do we say? Not AB, BC. Okay, I want to do BC. And I'm picking these two for a reason, okay? So don't worry about why I'm picking them, but you'll see. So I want to find the midpoint of BC. So it's probably around, I don't know, around in here somewhere. Maybe there, maybe. You think it's there? Probably. But do I want to go by probably? No. I want to figure out exactly where it is. So let's find the midpoint of BC. All right, shouldn't take too long. Put this over 2, put this over 2. BC, so I'm doing the second one and the third one. So what do? I add up the x's, 1 plus 7. Let's do it in our head. What's 1 plus 7? That's 8. And then -5 plus 3. -5 plus 3. -2. So what does that give us? This gives us 4, what? -1. Okay? So where is 4, -1? Let's do this in blue. So we stay a little color coordinated here. So 4, -1. So I go 1, 2, 3, 4, -1. Yep, that's right where I thought it was. And that's exactly where it is. You with me? Was I one off? I think I was on. Go what? Was I? I don't think so. Go back and look. Go back and look. All right. I've made mistakes before, but I think I did pick that point right there. So anyway, that's our point, okay? Now, what I want to do is 2 more things. I don't even care about those points right now. Watch this. Do you see this blue line right there? We have a special name for it, all right? We call it a mid-segment. Mid-segment. So that blue line, it's called a mid-segment. What did it do? What does it attach? It attaches this midpoint to what? To another midpoint. in a triangle. Everybody see it? See, this is a midpoint right here. This is a midpoint right there because we just found them. All right? Any line that connects two midpoints together in a triangle is called the what? The midsegment. There's two things that we know about a midsegment, and we're going to find them right now in about 3 minutes, okay? So let's do it. What is this point we say? This was what, 0, 2? Is that right? And this point was what, 4, -1? Okay. So what I'm going to do is I want to find two things. I want to find the slope of the blue line, and I want to find the length of the blue line. So let's find the slope first. So the slope of the blue line, or the midsegment. How do we find the slope? Subtract the x's or the y's from each other. 2 minus -1. 2 minus -1 over 0 minus 4. And what's that give us? 3 over 4. That looks familiar, doesn't it? Look back on your notes. What's the first thing we did today on our notes? We found the slope of AB, didn't we? What did we say the slope of AB was? 3 over 4, positive 3 over 4. So check this out. What's the first thing that we know about a midsegment? The midsegment and this third side, right? So here's 1, 2, 3 sides. This is the third side. Yes? It's the one that's not connected by the midsegment. So those two have the same what? Have the same slope. So they have the same slope. All right, so that's kind of interesting, right? Slope of this one is 3/4. We found the slope of this one was 3/4. All right, let's do something else, and then we will be pretty much done. Let's find the length of this midsegment. Find the length. So that's distance. Watch. So I'm going to do it pretty quick because of time. And what do? Subtract the x's. So 0 minus 4. Subtract the y's. 2 minus -1. And let's do the work. 4 squared is 16. This is 3 squared is 9. 16 and 9 is 25. But what's the square root of 25? 5. It's just the whole number 5. Check this out. The length of that is 5. You're like, well, okay, big deal. Okay, I didn't find the length of anything else. What did we find? Look in your notes. What did we find the length of AB to be? No, the length, the distance. What is it? It's 10. That's right. Do you remember that? Remember this was 10? Yes? All right. Now, check this out. So the midsegment, look at the difference between the midsegment and this third side right here. The midsegment is what? It's half. It is 5. He's right. He's not wrong. But I'm trying to go a little bit more general. The midsegment is how much of this third side? It's half of it, isn't it? Okay, it's half of the third side. So it has the same slope of the third side. All right, and the length of it is exactly half of the third side. And we just kind of did a proof. That's basically a coordinate geometry proof that we just did. Kind of. Not exactly, but it's pretty close to one. All right? So we just showed you that the midsegment, anytime I have a triangle, it doesn't matter what the triangle looks like. Anytime I have a triangle, if I find, I'm just going to do this kind of, okay, let's say that's a midpoint, and let's say that's a midpoint right there. If I connect the two midpoints, what did I just make? What's the name of it? It's a midsegment. And so that midsegment has two things. It's what? It's parallel to the third side, or to the opposite side, if you want to call it that. You see it? So they're parallel to each other. So let's put a little parallel thing. And it's also what? In distance. It's half of the third side. So if this was 3, what's the third side going to be? No, this is half of this. Okay, or we could say that the third side is twice as big as the midsegment, right? So if this is 3, that's got to be 6. You got it? All right. So look at that. Right on time. Pretty good timing, wasn't it? All right, so you're going to have 1 to 16. So look at, forget what page it is, but it's section 4.7, Call it 4.7a because we're going to do 2 of these. So call it 4.7a, and you're doing 1 to 16, and that's your homework. I don't know. Just look up section 4.7. You'll see it.